So um, it was determined that the most important chapters for getting ready for college level math in this course were trigonometry and geometry. So since we don't have a review week and then an exam, I'm going to cycle back this week on trigonometry and then the last week geometry and measurement. And that's going to end it. So you guys, in theory, would already have a lot of this stuff in your notes. I'm going to put a modified version of one of the shorter assignments that we did in trigonometry for you guys to try, and we'll go from there. All right. So if you remember, you can use SohCahToa to help you solve for the sides and angles in right angle triangles. That means one of the angles has to be 90 degrees. So if you need a little review here, here's your right angle triangle. This would be where the angle is right here. If that's where the angle is, then this is the opposite side, this is the adjacent side, and this is the hypotenuse. And the relations are sine theta equals opposite over hypotenuse, cosine of theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. I don't know why I switched to uppercase there. I just did. If you are following along with the calculator, you want to make sure that you're set in degrees. And let's just type in, first of all, sine 73. The degree sign is supposed to be up top, not on the bottom. I'm not sure why that didn't transfer over, but it's not a big deal. So I type sine 73, and it gives me 0.956. And then cosine 36 is equal to 0.809. And there are more digits than that. I just rounded it to 3 digits. And then the sine -1, it's supposed to be the power of -1. On your calculator, that's second function or shift on my calculator. So the first one would be shift sine, which makes it to the power -1. So I go shift sine and then 0.357. And it gives me 20.9 with 3 digits. And then shift tan of 3.4, and it gives me 73.6 to 3 digits, 73.6. And that would be giving you degrees. These here are just decimals, and then these, it's 20.9 degrees and 73.6 degrees, all right? So if you're following with your calculator, make sure you'll know that you're in the right format and the right frame of mind if you can do that. So just to start out, 35 degrees is the angle, 12 is the hypotenuse, and x is the opposite side. Opposite to the angle is what that means. So that's your opposite. The long side is your hypotenuse. So if we have the opposite and hypotenuse, then SoH, the first relationship, is the only one that fits. So you go sine 35 degrees equals opposite, that's the x, over hypotenuse, that's 12. You multiply both sides by 12 to get rid of the 12 on the right side. And then that's just going to be what x is. So I keep x on the right. And then over here, I've got sine 35 times 12. So I go sine 35 equals, and that's 0.573 and a bunch of other stuff. And then I hit times 12, and it makes 6.88 degrees equals x. You can pause this video at any time to make sure that you can get the right answer on your calculator. Next example, I've got 40 degrees, the opposite side. Again, x is the opposite side. And this is the hypotenuse over here. In this case, it gives me the adjacent side. So which one does that? That is tan, opposite and adjacent. So that's going to be tan 40 degrees is equal to opposite, that's x, over adjacent side, that's 8. You're going to do the same process before. Multiply both sides by 8 to get rid of the 8. Keep x over on the right. And I go tan 40 equals, and then times 8, which makes 6.7 degrees. It's that easy. That easy to do right angle triangles. Here's another one. This time I don't know the opposite side. I know the hypotenuse, the long side, and the adjacent. That's the side that's it's right next to the angle, but not the hypotenuse. So we have the adjacent side. So that's going to be the cosine of the angle. This time that's what we don't know, is equal to adjacent 15 over hypotenuse 19. All right. So type into your calculator 15 divided by 19, and it's 0.789. And over here I've got cos theta. And you may or may not remember that to move the cosine over and get the angle by itself, it's the cosine to the power of -1 of 0.789. So on your calculator, you go shift, or second function, cos 0.789, and if you do it correctly, you'll get 37.9 degrees. Pause the video if you want to try and punch that into your calculator. Determining the value of the angle again, it's almost the same. I've got the side opposite to the angle, and I've got the hypotenuse this time. So this time it's going to be opposite and hypotenuse. That's sine, saw. So sine theta is equal to 8 divided by 11, opposite over hypotenuse. So 8 divided by 11 is equal to, 8 divided by 11 is equal to, oh man, eight divided by 11 is equal to 0.727. So sine theta is equal to 0.727. Had a little technical difficulty there with my calculator. And then just like before, to find the angle, you have to go sine inverse or shift sine or whatever it is on your calculator, 0.727. So I'm typing in shift sine on my calculator right now. Shift sine 727 is equal to 46.6 degrees. Here's another one here. A little bit more complicated. We know all the stuff in the top triangle, and we want to figure out what x is in the bottom triangle. That'd be the hypotenuse of that triangle. So the first thing I'm going to do is try and figure out what this side is, since that side is shared between both triangles. And if I'm looking at the 40 degrees, then that side I want to find out is the adjacent side to the 40 degrees, and I've got the hypotenuse. So adjacent and hypotenuse is Ka, or cosine of 40 degrees, is equal to the adjacent side, I'm just going to call it A, because they don't have it labeled, over 35. You've got to multiply both sides by 35, just like the first couple of examples that we had. And that's going to give us what A is, because that cancels that out. So I go 35 times cosine of 40 degrees, and it makes 26.8. And I'm going to leave that there. I'm going to write it in here, 26.8. Now in my second triangle, that would actually be the opposite side to the 62, and this is the hypotenuse down here. So opposite and hypotenuse is going to be sine 62, that's saw for in SohCahToa, is equal to the opposite side, that's 26.8, divided by the hypotenuse. Now this one's tricky to solve for because the unknown's on the bottom. We haven't seen that yet. So if I multiply both sides by h, I should get there. That cancels the h on this side, and it's going to leave an h on that side. So it's going to be sine 62 times h equals 26.8. Now that still doesn't have it solved for. We got to get rid of the sine 62. So you divide both sides by sine 62. Cancel, cancel, and now I have h equals just 26.8 divided by sine 62, which is 30 decimal 4. And it doesn't give us units. That's a side length, not an angle, so it's not degrees. And anyway, that's what it is, 30.4. And like I said, I'm going to have a worksheet attached to this, but I want to do a few more examples with you first. We'll keep our annotations in that one. I have another PowerPoint here, more right triangles. So we did this in 2 days, and I'm just doing it all at once right now. If I can get it opened, that is. There we go. And, it's just more of the same, guys. At this point, you can check out at any time that you want and go ahead and do the work. So I've got 25 degrees. We're trying to solve for the opposite side. So I'm going to go a little quicker here now that these are getting more repetitive. So sine 25 is equal to x. Oh, I messed that up. Good catch. Whoever caught that. It's not sine, it's opposite, and it's adjacent. It's drawn kind of upside down. The right angle is there. This is the hypotenuse here, and I almost got caught by that. So it's actually going to be tan 25 is equal to x, the opposite, over the adjacent, TOA. And you're going to end up having to multiply the 7 over there, so it's going to be 7 times tan 25. I hit equals, and it gives me 3.3. X equals 3.3. There's no units on that, so you are done. If this was a test, I'm just checking to see, did you set it up right? Did you get the right answer? That's it. Just out of 2. You might remember this bad one from as one of your test questions, and you had kind of a major assignment early on, maybe week 2 or 3, on something like this. So it's 2 triangles, and we're trying to figure out all the angles in that triangle. The first angle, alpha, is actually pretty easy to solve for because you've got the 2 sides. You've got the adjacent and the opposite. So why don't we find that first? I'm going to do it right underneath it, and we're going to say tan of alpha is equal to opposite over adjacent. So that's 4 over 5. So I got to type in 4 divided by 5 equals, and it's 0.8, obviously. And then I got to go tan inverse of 0.8, which is 38.7 degrees. So alpha is 38.7 degrees. That part's done. Now to find the value of beta, first what we're going to need to do is find out what this entire angle is, because we know for the whole big triangle, we know that length, 6 and 4, is 10. So I'm just going to redraw it right here for you so you can see. So I'm going to solve a triangle with this big angle here, alpha and beta together. That side length is 10, and this side length is still 5. So I'm going to go tan, and I'm just going to call it theta, since that wasn't already being used. And opposite over adjacent is 10 over 5. So I go 10 divided by 5, which is 2. And then I go shift tan, and it gives me an angle, if you type it in the right order, of 63.4 degrees. So if the whole thing is 63.4 degrees and alpha is 38.7 degrees, then we should be able to figure out what beta is by just doing a subtraction. The whole thing's 63.4, so I'm going to subtract 38.7, and it tells me that that's 24.7 degrees right there. So beta is 24.7 degrees from that subtraction. That's about as tough as they get. I got a couple word problems I'm going to finish off with here. One's on angle of elevation and one's on angle of depression. So angle of elevation would be, it's like there's an imaginary horizontal line, and angle of elevation would be the number of degrees it is above the horizontal line. Angle of depression is similar, where you've got this horizontal line, and it's the number of degrees below that horizontal line. So let's do this. A helicopter sees its landing pad at an angle of depression of 32 degrees. So I'm just going to draw that real quick. So depression's like this, and it's 32 degrees. If its altitude is, oh, here we go. Altitude is distance, height. Its altitude is 225 feet. What is the shortest distance it could travel to reach the landing pad? Shortest distance will be the straight line. That's the hypotenuse right there. So we go, it's opposite in hypotenuse. So it's going to be sine 32 degrees equals opposite, which is 225 divided by hypotenuse. I'm going to just put an h in for that. This is like one we saw a little ways back. It is a bit of a pain to solve for the thing that's in the bottom of your equation because I got to multiply both sides by h. So it's going to be sine 32 times h equals 225 feet. And then I got to divide both sides by sine 32. Divide by sine 32. And you end up with h equals whatever 225 divided by sine 32 is. And I got 424.6 feet as my hypotenuse. That's word problem number one. Pause it if you need to think about it. Last one. You're standing on the top of a 12-meter building. The angle of depression to the bottom of a neighboring building. Ooh, two buildings. All right. So to simplify things, I'm going to make my buildings sticks. Here's building one. Here's building two. Because it says the angle of depression to the bottom of a neighboring building. You're on the top of building the first building. The angle of depression to a neighboring building is 32 degrees. Remember that angle of depression means below an imaginary horizontal line. The angle of elevation to the top of the other building is 38 degrees. Oh, I'm going to have to change my building a little bit because it's a taller building. This is not being drawn to scale by any stretch of the imagination. So to the bottom of the building is 32 degrees, and to the top of the building it's 38 degrees. So that's what we've got right there. Determine the distance between the buildings. And I'm going to write in that this is a 12-meter high building. And then B says determine the height of the second building. So the distance between the two buildings can be found, well, it can be found right here. Here's the first building, here's the second building. So why don't we go ahead and find that? Another way to do it would be to find this distance right here, which would be the same. I guess that makes sense. And this height's also going to be 12 meters. So 32 degrees, we've got the opposite side, and we're trying to find not the hypotenuse, but the adjacent side. So in the first triangle, the bottom triangle, it's going to be A. So opposite and adjacent is tan. So here we go. Tan 32 is equal to opposite, that's 12 meters, over adjacent. Again, it's a bit of a pain because the variable's in the bottom. That cancels the A out, and you've got tan 32 degrees times A is equal to 12 meters. Last thing you do is you divide both sides by 32, or tan 32, I should say. That gets rid of it there. And the answer to that adjacent side, or the distance between buildings, is 12 divided by tan 32. And it's 19.2. 19.2, and that is in meters. So there's part A done. I'll label that as part A. Part B says, what is the height of the second building? Well, we already know that from here to here, it's 12 meters. So all I need to figure out then is that height right there. We now know that this is 19.2 meters right here. We know that's 38 degrees, so we're just solving for the opposite side. This is the hypotenuse. We're solving for the opposite. So let's go tan 38. Why tan? Because it's opposite and adjacent that we're dealing with. I'm going to call it O. And I'm going to divide it by 19.2 meters. This one's a little easier to solve because multiplying both sides by 19.2 is all you really need to do. That gets rid of the 19.2 on that side, and that'll solve for O. It's an O, not a 0. So I'm going 19.2 times tan, 38, and it gives me 15 meters almost exactly. I'm going to circle that because it's important, but I'm going to say the height is equal to, what was it, 12 meters from there to there, and then a further 15 meters. So 12 plus 15 is equal to 27 meters, and that is the answer to B. We solved B. A little bit sloppy as I'm pressed for space on this PowerPoint. But that's it, guys. That takes you through all of your right angle mathematics, right angle triangle mathematics. And I will post a short assignment to go with that. You've already gone through this stuff, so handing it in is going to be optional. I'll mark it if you hand it in, and if you're good to go on just doing it yourself and checking your answers, then that's fine. I am going to have the answers posted with it, so you should know whether or not you know what you're doing. Please email me if you're stuck. Like I said, this chapter and also the geometry chapter seem to be the consensus most important going into college. So that's why we're circling back on these two chapters. All right, guys, good luck with your work, and we're almost there.